Welcome to my first of two tutorials about spline curvature. Let's start by creating two lines that cross. And right-click, done. Here's my second line. Let's apply a coincident constraint between the midpoints of the two lines. Right-click and done. Now let's apply some dimensions. The longer line will make 2 inches. OK, and the shorter line will make half of the length of the first line. Now I'm going to create 4 elliptical closed-loop splines. And close. Right-click, done. Let's make this spline red. Right-click, Properties. We'll change the line color. Apply and OK. Now let's do another spline starting from a different point. Close the loop as well. Right-click, done. I'm going to change the color of my second spline. Right-click, Properties. Line color, let's make it green. Apply and OK. 2 more splines to go. Activate the spline tool. Now we'll start from this point. There's a method to my madness I will explain shortly. Let's close the loop. Right-click, done. And let's select our most recent spline and change this color as well. Right-click, Properties. Let's change the line color to magenta this time. Apply and OK. 1 more spline. And let's start from this point. We'll close the loop and right-click, done. Let's zoom in a little bit. As you can see, the splines are obviously not identical, and that's because the curvature at any given point of a spline depends upon where the spline starts and ends. Let's make some minor adjustments that make this effect even more pronounced. Let's begin by activating the Show Constraints tool. It's on the Constrain panel. Right-click, done. Let's delete the coincident constraint here. And let's grab this line and drag it up and down a little bit. Now you can see that the effect in the difference of curvature is much more pronounced. We're able to change how spline data points fit on a spline. We use what's called the fit method. There's a few different fit methods available to us in Inventor. Right-click on a spline point and select Fit Method. There's 3 options here: Standard, AutoCAD, and Minimum Energy. Actually, let me show you this menu from a different point so that the flyout fits better in my screen. The AutoCAD method is the same method that's used by AutoCAD. The Standard method generates a curve with a smoother continuity than the spline fitting method of AutoCAD. The Minimum Energy option, this generates an even smoother curve than the Standard method. A spline contains a lot of data actually, and the more of this data you use, the smoother the curve will be. And correspondingly, a surface that's generated from a minimum energy spline method requires more computer power to process than the other 2 methods we covered here. Let's change the fit method to minimum energy for all 4 of our splines. Right-click, select Fit Method, and then Minimum Energy. Fit Method, Minimum Energy. And the red spline, Fit Method, Minimum Energy. 1 more to go. Fit Method, Minimum Energy. As you can see, there is a significantly better curvature distribution. Okay, let's undo and restore to the previous fit method. Now let's apply a coincident constraint between this point and this point. Right-click, done. Let me create another line here. Right-click, done. And activate the line tool again. Let's create a line here. Right-click, done. Now let's activate the spline tool. We'll create a spline between these 2 points. Right-click, Done. Right-click, Properties. We'll make this new spline black. Apply and OK. Now let's add a tangency between the spline and the lines I just created. Right-click, Done. Let's create one more spline. Right-click, Create. Right-click, Done. Right-click, Properties. Let's make it yellow. Let's apply a smooth constraint as well between the spline and this line, and between this spline and this line. Right-click, Done. Let's right-click, Display Curvature. Let's right-click on this spline as well. Display Curvature. As you see, for the G2 continuity or smooth method, the transition is indeed much smoother at this point. Let's create one more spline. It'll be between these 3 points. Right-click, Create. Right-click, Done. As you see, the curvature depends upon the method that you use to create the spline. I'm going to pick up from here in my next tutorial. This concludes my first chapter on spline curvature.